So, good morning, students. Good afternoon. So, let's start today's session. So, in the previous session, we have discussed about k nearest neighbor algorithm, and in today's session, we're going to discuss about decision tree algorithm. Okay. So, in this algorithm, we are going to take some examples, and we're going to implement the decision tree algorithm from the scratch, and after that, so we can use the library functions to implement the decision tree algorithm. Okay, so first let us see what is decision tree and how it is working, and all how the algorithm runs, and how the calculations has been happened. So those things we shall discuss now. Okay, so decision tree algorithm, firstly, it is widely used and very intuitive, visualizable supervised machine learning algorithm that uses flowchart like structure that make the decisions or the predictions. Okay, like how the tree has been made, tree has been created, right? In the similar fashion, this algorithm going to create a tree. Okay, so so let me just show you the simple example. So using this algorithm, so we're going to have this kind of tree. Okay, so we're going to have the root node, we're going to have the decision node, we're going to have the leaf node. So this algorithm going to consider entire data set, whatever the information that we have given to this algorithm for solving a problem. So it is going to consider an entire data set, and it will start creating the tree starting from the root node, and it will start creating the intermediate nodes, and finally it stops as soon as it reaches the leaf nodes or the end points. Okay, so thereby it is going to create a tree. Okay, and how the result will be given is like, since this algorithm is best suited algorithm for classification problems, the classifications or the classes or the categories or the labels will be decided based on the path that it is followed. Okay, so by considering the features, values for those features. Okay, so how the path has been taken and it reaches the leaf node finally, and this leaf node is what your class or the label. Okay, so for example, so let me consider a simple example. Okay, consider you are going to offered with some company, right? So you have attended some interview in your college. Okay, so they have offered, right? So we will be offered with 2-3 companies. Okay, how you are going to decide whether you are going to accept or reject that offer? Okay, can I know? May I know how you are going to decide whether you are going to accept or reject that offer? Okay, first thing, what you are going to consider? Simply they have given the offer letter, is this enough? So no matter about the package, no matter about where it is lying, where you have to work, whether it is a remote job or a office job, in office job, or whether it is a day shift or a night shift, whether they are giving us some sufficient salary, right? So you have certain criteria that has to be satisfied in with you, right? So is that so? ಅನ್ಸುತ್ತಲ್ವಾ? So you will be having certain requirements that even like, for example, if some if ABC named company is giving you offer with 10 lakhs package, 10 lakhs per annum, but it is residing far away from your place and they are not providing any accommodation, and they have not providing any leaves and all. So is this okay? See whether you're going to accept that offer just by seeing the package. Let me know. ಹೌದಾ, ಅಕ್ಸೆಪ್ಟ್ ಮಾಡ್ಕೊತೀರಾ? ಹೇಳಿ ಮಾತಾಡಿ. You people have to talk. Okay. Except like imagine you receives a job offer from the company A or ABC. So you must decide whether to accept or accept it now or wait for another offer. Okay, so you are in this situation. Okay, so accepting a job offer scenario. Okay, so whether you are going to accept the offer right now or not. Okay, so how you are going to decide? Okay, let me just give it. Okay, so first criteria that you are going to see is what? ಏನು ನೋಡ್ತೀರಾ ಫಸ್ಟು? ಜಾಬ್ ಆಫರ್ ನಿಮಗೆ ಬಂದಿದೆ ಅಂದಿದ ತಕ್ಷಣ, ಸೊ ವಾಟ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಿ ಫಸ್ಟ್? ವಿಚ್ ಕಂಡೀಷನ್, ವಿಚ್ ಫೀಚರ್, ವಿಚ್ ಥಿಂಗ್ ದಟ್ ಯು ಕಾನ್ಸಂಟ್ರೇಟ್ ಫಸ್ಟ್? ವೆದರ್ ಪ್ಯಾಕೇಜ್, ಪ್ಲೇಸ್ ಆರ್ ಮೋಡ್ ಆರ್ ಅಕಾಮಡೇಷನ್ ಆರ್ ವಾಟ್? Okay, so let us consider. So your package lies the first thing. Okay, so if package is greater than 10 lakh 10 LPA, then you are going to see. Okay, one the 20 lakh ಅನ್ಕೊಳ್ಳಿ, so no chance of rejection. Okay, so ಒಂದು accept ಮಾಡ್ತೀರಾ ಅಥವಾ ರಿಜೆಕ್ಟ್ ಮಾಡ್ತೀರಾ ಅಲ್ವಾ? ಓಕೆ, ಸೊ accept ಮಾಡೋದಾದರೆ ಒಂದು, ರಿಜೆಕ್ಟ್ ಮಾಡ್ತೀನಿ. ಓಕೆ, ಸೊ ಇಫ್ ಪ್ಯಾಕೇಜ್ ಈಸ್ 20, ಓಕೆ, ಸೊ 20 LPA ಇದೆ ಪ್ಯಾಕೇಜಲ್ಲಿ. ಓಕೆ, ಸೊ ಅಷ್ಟೇ ಸಾಕಾ? ನೋ, ರೈಟ್? ಸೊ ಜಸ್ಟ್ ಗೋ ಫಾರ್ ಅನದರ್ ರಿಯಾಕ್ಷನ್. ಇಫ್ ಲೆಸ್ ದ್ಯಾನ್ ದಟ್ ರಿಜೆಕ್ಟ್ ಮಾಡಿಬಿಡ್ತಾರೆ, ಡೈರೆಕ್ಟ್ಲಿ ರಿಜೆಕ್ಟ್ ಮಾಡಿಬಿಡ್ತಾರೆ. ನಂಗೆ ಬೇಡ ಯಾಕಂದರೆ ಮಿನಿಮಮ್ ಸ್ಯಾಲ್ರಿ ಎಕ್ಸ್ಪೆಕ್ಟೇಷನ್ ನಾನು 20 LPA ಇದೆ, ಸೊ ಐ ಡೋಂಟ್ ವಾಂಟ್ ಎನಿ ಜಾಬ್ಸ್ ವಿಚ್ ಇಸ್ ಲೆಸ್ ದ್ಯಾನ್ ದಟ್. ಓಕೆ, ಸೊ ಡೈರೆಕ್ಟ್ಲಿ ರಿಜೆಕ್ಟ್. ಸೊ ಇಫ್ ಇಟ್ ಈಸ್ ಗ್ರೇಟರ್, ಓಕೆ, ಇತ್ತು ಅಂದರೆ, ಸೊ ಯು ಗೋ ಫಾರ್ ಅನದರ್ ಕಂಡೀಷನ್, ವೆದರ್ ಇಟ್ ಈಸ್ ಅ ಡೇ ಶಿಫ್ಟ್. ಓಕೆ, ಸೊ ಡೇ ಶಿಫ್ಟ್ ಹೌದೋ ಅಲ್ವೋ? ಓಕೆ, ವಿಲ್ ಜಸ್ಟ್ ಸಿ. ಓಕೆ, ಚೆಕ್ ಮಾಡಿದ್ರೆ ಡೇ ಶಿಫ್ಟ್ ಆಗಿದ್ದರೆ ಓಕೆ, ಎಸ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಅಕ್ಸೆಪ್ಟ್. ಓಕೆ, ಆರ್ ಡೇ ಶಿಫ್ಟ್ ಅಲ್ಲ ಅಂದರೆ ಆ ಸ್ಟೇಜಲ್ಲೇ ರಿಜೆಕ್ಟ್. ಓಕೆ, ಇಫ್ ಡೇ ಶಿಫ್ಟ್ ಆಗಿತ್ತು ಅಂದರೆ ಅಷ್ಟೇ ಸಾಕಾ? ಸೊ ನೆಕ್ಸ್ಟ್ ನೋಡ್ತೀವಿ. ಪ್ಲೇಸ್ ಆಫ್ ವರ್ಕ್ ನಿಯರ್ ಇದನ್ನ ಫಾರ್ ಇದನ್ನ. ಓಕೆ, ಸೊ ನಿಯರ್ ಇದನ್ನ ಫಾರ್ ಇದನ್ನ ಚೆಕ್ ಮಾಡ್ತೀರಾ. ಓಕೆ, ಫಾರ್ ಇತ್ತು, ತಲೆನೇ ಕೆಡ್ಸ್ಕೊಳಕ್ಕೆ ಹೋಗಲ್ಲ, ಯು ಜಸ್ಟ್ ರಿಜೆಕ್ಟ್ ಇಟ್. ತುಂಬ ದೂರ ಹೋಗೋಕ್ಕೆ ಹೋಗಲ್ಲ, ನನಗೆ ಓಡಾಡೋದು ಕಷ್ಟ, ಅಥವಾ ತುಂಬ ಅಷ್ಟೆಲ್ಲ ವರ್ಕ್ ಮಾಡೋಕ್ಕೋದ್ರೆ ನಾನು ಸ್ಟ್ರೆಸ್ ಆಗೋಗಿ ಸುಸ್ತಾಗೋಗಿ ಪ್ರಾಪರ್ ನಂದು ಪ್ರೊಡಕ್ಟಿವಿಟಿ ನಾನು ಕೊಡೋಕ್ಕಾಗಲ್ಲ. ಓಕೆ, ಸೊ ದ್ಯಾಟ್ ಥಿಂಗ್ ಯು ಹ್ಯಾವ್ ಟು ಡೂ. ಇಫ್ ಪ್ಲೇಸ್ ಆಫ್ ವರ್ಕ್ ಈಸ್ ವೆರಿ ನಿಯರ್, ವೆದರ್ ದೇ ಆರ್ ಫೆಸಿಲಿಟಿ ಪ್ರೊವೈಡಿಂಗ್ ಅ ಕ್ಯಾಬ್ ಫೆಸಿಲಿಟಿ, ಲೈಕ್ ಫಾರ್ ಅವೇ ಇತ್ತಂದರೆ ಕ್ಯಾಬ್ ಫೆಸಿಲಿಟಿ ಕೊಡ್ತಿದ್ದಾರಾ? ಓಕೆ, ಸೊ ಅದನ್ನು ನೋಡ್ತೀರಾ. ಸೊ ಫಾರ್ ಇತ್ತು ಅಂದರೆ ಕ್ಯಾಬ್ ಫೆಸಿಲಿಟಿ ಕೊಟ್ಟರೆ ಹೋಗ್ತೀರಾ, ಇಲ್ಲ ಅಂದರೆ ಹೋಗಲ್ಲ. ಓಕೆ, ಸೊ ಪ್ಲೇಸ್ ಆಫ್ ವರ್ಕ್ ಈಸ್ ನಿಯರ್, ಸೊ ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಅಕ್ಸೆಪ್ಟ್ ಇಟ್. ಓಕೆ, ನಿಯರ್ ಇತ್ತು ಅಂದರೆ ಅಕ್ಸೆಪ್ಟ್ ಮಾಡ್ತೀರಾ. ಫಾರ್ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ, ಓಕೆ, ನೀವು ಅದರಲ್ಲೂ ಕಂಡೀಷನ್ ನೋಡ್ತೀರಾ, ಕ್ಯಾಬ್ ಫೆಸಿಲಿಟಿ ಕೊಡ್ತಿದ್ದಾರಾ, ಟ್ರಾನ್ಸ್ಪೋರ್ಟೇಷನ್ ಫೆಸಿಲಿಟಿ ಇದೆನಾ? ಇಲ್ಲ ಅಂದರೆ ಇದ್ದರೆ ಓಕೆ ಅಕ್ಸೆಪ್ಟ್ ಮಾಡ್ತೀರಾ, ಇಲ್ಲ ಅಂದರೆ ರಿಜೆಕ್ಟ್ ಮಾಡ್ತೀರಾ. Okay, so these are the things that you are going to see more oftenly, right? So this is how, this is just a simple scenario for simple example, okay, whether you are going to accept a job offer or not. Okay, first thing what you are going to see, ಲೈಕ್ ಎಲ್ಲದಕ್ಕಿಂತ ಇಂಪಾರ್ಟೆಂಟ್ ನಿಮ್ಮ ಪ್ಯಾಕೇಜ್. ನಿಮಗೆ ಡೇ ಶಿಫ್ಟ್ ಇದ್ರೂ, ಪ್ಲೇಸ್ ಆಫ್ ವರ್ಕ್ ನಿಯರ್ ಇದ್ರೂ, ಅಕಾಮಿಡೇಷನ್, ಟ್ರಾನ್ಸ್ಪೋರ್ಟೇಷನ್ ಅಕಾಮಿಡೇಷನ್ಸ್ ಎಲ್ಲ ಕೊಡ್ತಿದ್ರು, ಪ್ಯಾಕೇಜ್ ಕಡಿಮೆ ಇದ್ದರೆ ನೀವು ಹೋಗಲ್ಲ. ಓಕೆ, ಸೊ ದಟ್ಸ್ ದ ಫಸ್ಟ್ ಕ್ರೈಟೇರಿಯಾ ದಟ್ ಲೈಕ್ ಯಾರಾದರೂ ಆಗಿದ್ರು ಫಸ್ಟ್ ಕ್ರೈಟೇರಿಯಾ ನೋಡೋದೇ ಅಲ್ವಾ. ಸೊ ದ್ಯಾಟ್ ಇಟ್ ಸೆಲ್ಫ್ ಈಸ್ ಯುವರ್ ರೂಟ್ ಪಾಯಿಂಟ್, ಮೇನ್ ಫೀಚರ್ that you are going to consider for making the decision, right? So after that only, which is the next priority, which is important for us, so that we are going to take out in the tree structure. Okay, so this exactly how the decision tree is going to work. Okay, so this is how the decision tree is going to make the decisions by creating the trees. Okay, and by considering the root node, these are all the branch node, and this is where these branches, how it is going to take depends on the number of decisions it can make for this feature. Okay, so this is how the decision tree exactly going to work out. Okay, but a small changes how we think of our priority. The decision tree is going to think of the priority, but we think of like our comfortness, but with the decision tree algorithm think of the priority based on some calculations, based on some metrics. Okay, so and those metrics are entropy, Gini index, okay, so information gain, okay, simply called as gain. Okay, so these are the different metrics that the decision tree algorithm going to see for building the trees, to make the decisions, to classify, to predict the classes. Okay, so this is how the decision tree is going to work out. The decision tree is going to see this the results. Okay, so let me take another example. So does the person likes the computer games or not? If the age is less than 15, no, he don't use Python computer program, because most often they used to see for cartoons and all. So if more than 15 years of age, it's like most commonly, so yaragidruno, if it is male or female, they used to play the computer games with a more interest. Okay, so that is how the decisions going to make out based on the priorities, based on the preferences. Okay, so it will just check the conditions, and based on this it will split up the groups, and each groups will give you the results. Okay, again that group can be splitted again, so to make the next subtree. Okay, so likewise the tree keeps on developing until it reaches the end node, or one leaf node na reach agavaru, or else on the certain levels of trees na reach agavaru, specified levels na matra ನಾವು ಕ್ರಿಯೇಟ್ ಮಾಡಿ ಅಂತಾನೆ ಕೊಡ್ಬೋದು. ಸೊ ಅಷ್ಟು ಲೆವೆಲ್ಸ್ ನಾವು ರೀಚ್ ಮಾಡೋವರೆಗೂ ಟ್ರೀ ಬಿಲ್ಡ್ ಆಗ್ತಾನೆ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ಐ ಕ್ಯಾನ್ ಜಸ್ಟ್ ಶೋ ಯು ಹಿಯರ್. So this is how the decision tree is going to create. Okay, so starting from the root node, it will go to the next nodes and keeps on developing it. It's not mandated that always it will be 2 branches from the node. Okay, it can be 3, it can be 4, it can be 5. So it depends on the number of unique features in the particular data set. Okay, particular feature. Okay, so this is how that final tree will be created after implementing the algorithm. Okay, so let us just start applying this algorithm for a problem statement. Okay, so let me just have a data set. And for that data set we shall solve the problem using decision tree algorithm. Okay, consider, so this is our data set. Okay, so which contains the features like day, outlook, temperature, humidity, wind and play. Okay, so what is this saying? Okay, what is our problem statement actually? So we have to predict whether a child or a kid going to play in the outside ground based on the environment, based on the weather conditions. Okay, what does weather condition includes? So it contains outlook, how the outlook is present, outlook is there for a particular day, what is the temperature of that particular day, and what is the humidity and wind, so whether it is weak, strong, not. Okay, so likewise we'll be having different certain features, the certain characteristics of the weather. So using all these things, we have to predict whether the child is going to play in the play today or not. Okay, outside ಹೋಗಿ play ಆಡ್ತಾರೋ ಇಲ್ವೋ ಅನ್ನೋದನ್ನು ನಾವೀಗ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಲೈಕ್ so we have 14 days information. Okay, so we have 14 days of information. So in the day 1 we'll be having a sunny outlook and a hot temperature, high humidity and a weak wind. So since the temperature is too hot and humidity is too high, so the child is not gone for play. Okay, so playing outside. And in the day 2, so even though that even added a feature like a wind was very strong, so the child didn't play. So in the same similar fashion we'll be having a 14 days of information. Okay, what like past 14 days information, based on that we have to predict when on the 15th day. So based on outlook, temperature, humidity and wind, how the condition is present, so we have to find out whether the child is going to play outside or not. Okay, so let us just solve this by using the decision tree algorithm. Okay, so first, as I said, the decision tree algorithm, how it is started. First thing, it will going to start with finding out the root node. Okay, so how the decision tree is made? So decision tree first creates the root node first. So it will select step 1. So let us take in as algorithm. Okay, so in the step 1, okay, it will find out the best feature. Okay, and select this as root feature. Okay, so ಇಲ್ಲಿ ನಾವೇನು ಹೇಳ್ತಾ ಇದ್ದೀವಿ, root ಅಂತ ಹೇಳಿದ್ರೆ, so here this root node, decision node is nothing but a features again. Okay, so as we have temperature, humidity, wind, outlook and play, and in our example package, shifts, place of work, cap facility, so these are all the features. Okay, so ಈ ಫೀಚರ್ಸ್ನ ನಾವು ನೋಡ್ಸ್ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋತೀವಿ. Okay, so first we need to consider which feature should act as a root feature, which is the main one, which is the important one. So we have to find out the best feature. Okay, so in this algorithm, so we'll find out the best feature which is considered as the root feature. Okay, so we'll select. So the core process of building decision tree involves the top down approach, that greedy approach. Okay, so it will build the tree from the top to down. Okay, so first we are going to select the best attribute or a best feature. So here the algorithm evaluates all the features in the data set to determine the one best splits in the data into the purest possible subsets. ಓಕೆ, ಅಂದರೆ ಇರೋಂಥ ಎಲ್ಲ ಡಾಟಾ ಸೆಟ್ಟನ್ನು ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು ಯಾವ್ಯಾವ ಫೀಚರ್ಸ್ ಇದೆ ಎಲ್ಲನೂ ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು ಇಟ್ ವಿಲ್ ಗೋಯಿಂಗ್ ಟು ಫೈಂಡ್ ಔಟ್ ದ ಬೆಸ್ಟ್ ಫೀಚರ್. Okay, how the best feature has been selected? So as I said, it will going to use some metrics. Okay, so and those metrics are Gini index, information gain and entropy. Okay, any one will be used. So okay, gain, Gini index. Okay, so entropy, information gain and Gini. Okay, so these are the different metrics that decision tree algorithm, which is also called as ID3 algorithm, will use to find out the nodes. Okay, so what does it entropy mean, what does this gain mean, and what is this Gini means? Okay, so these are all nothing but the metrics which is used to find out the purity of the particular feature. Okay, so purity in the sense ಯಾವಾಗ like will be having a certain features, right? And that feature will be having a different values. Okay, so different set of values ಇರುತ್ತೆ ಅಲ್ವಾ. ಸೊ ಅದರಲ್ಲಿ ಲೆಟ್ ಮಿ ಜಸ್ಟ್ ಶೋ ಯು ವಿತ್ ಎಕ್ಸಾಂಪಲ್. ಸೊ ಅದರಲ್ಲಿ ನಮಗೇನಿದೆ, ಸೊ ವಿ ಕ್ಯಾನ್ ಹ್ಯಾವ್ ಔಟ್ಲುಕ್ ಈಸ್ ಎ ಫೀಚರ್. Okay, so we have sunny, overcast, rain, overcast. We have mix of classes, unique values here, right? We don't have any unique values here, right? For the sunny, you'll be having like always whenever the environment is sunny, we'll be having no as a result, right? Sunny, sometimes it is yes also, right? Sometimes you just ಔಟ್ಲುಕ್ನ ನೋಡಿ, ಇಲ್ಲಿ ಸನ್ನಿ ಓವರ್ಕಾಸ್ಟ್ ರೈನ್ ಅಂತ 3 ಕಂಡೀಷನ್ ಇದೆ. ಈ 3 ಕಂಡೀಷನನ್ನು ನಮ್ಗೆ ಯಾವಾಗಲೂ ಪ್ಲೇ ಮಾಡೋಕ್ಕೆ ಲೈಕ್ ಚೈಲ್ಡ್ ಹೋಗಿದ್ದಾನೆ ಹೊರಗೆ ಆಟಾಡೋಕ್ಕೆ ಅನ್ನೋದನ್ನು ನೋಡಿ. ಸೊ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ವಿ ಡೋಂಟ್ ಹ್ಯಾವ್ ದ ಯೂನಿಕ್ ಲೈಕ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಫೀಚರ್ ಆಫ್ ದ ಔಟ್ಲುಕ್ ವಿಚ್ ಸೇಸ್ like always it is saying when in this condition the child used to go for playing, right? So nothing like that, right? So in such type of things like ಅಂದರೆ ಇಲ್ಲಿ ನೋಡಿ, ಸೊ ಒಂದು ಫೀಚರ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊತೀವಿ, ಆ ಫೀಚರಿಂದ ಬರುವಂಥ ಔಟ್ಪುಟ್ಟಲ್ಲಿ ಸೊ ವಿಚ್ ಫೀಚರ್ ಇಸ್ ಗಿವಿಂಗ್ ಯು ದ ರಿಸಲ್ಟ್ ಈಸ್ ಕಂಟೈನಿಂಗ್ ಮಿಕ್ಸ್ ಆಫ್ ಬೋತ್ ಟೈಪ್ ಆಫ್ ರಿಸಲ್ಟ್, ಮಿಕ್ಸ್ ಆಫ್ ಕ್ಲಾಸಸ್, different classes. Okay, then such type of class feature will be considered as the impure one. Okay, so when the particular feature is showing the single output classes or it is fully homogeneous, okay, like whatever might be the feature, the output will always be the yes only, or output always be no only. Okay, so then such kind of feature will be called as pure feature. Okay, so ಅದೇ ಥರ ನೀವು ಇಲ್ಲಿ ನೋಡಿದ್ರೆ ಲೈಕ್ ಇಲ್ಲಿ ಮಿಕ್ಸ್ ಆಫ್ ವ್ಯಾಲ್ಯೂಸ್ ಎಲ್ಲ ನೋಡಿದ್ರೆ ಸೊ ಇಟ್ ಈಸ್ ಹೈಲಿ ಇಂಪ್ಯೂರ್. ಓಕೆ, ಹೈಲಿ ಇಂಪ್ಯೂರ್, ಇಟ್ ಈಸ್ ಹೈಲಿ ಪ್ಯೂರ್ ಅಂತ. ಓಕೆ, ಸೊ ಇದನ್ನೇ ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀವಿ, ಕಂಪೇರ್ ಮಾಡ್ತೀವಿ. ನಮ್ಮ ಡಾಟಾ ಸೆಟ್ಟಲ್ಲಿ ಯಾವುದು ಪ್ಯೂರಿಟಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಆ ಫೀಚರ್ನ ನಾವು ಫಸ್ಟು ಇಲ್ಲಿ ರೂಟ್ ನೋಡಾಗಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊತೀವಿ. ಆ್ಯಂಡ್ ವಾಟ್ ಎವರ್ ದ ಫೀಚರ್ಸ್ ವಿ ಹ್ಯಾವ್ ಇನ್ಸೈಡ್ ಇನ್ our data set, so we are going to find out the purity. Okay, so we are going to find out the purity based on the entropy. Okay, so and information gain. Okay, so entropy and information gain will give you, will checks for the purity and it will find out the best feature. Okay, how that is going to be calculated? Okay, let me show you the example for this data set. Consider this data set only. For this data set, so let us consider the outlook feature first. So consider attribute outlook. So considering this outlook attribute will be having a values like sunny, overcast and rain, right? So we will be having different unique values here. Okay, so let us consider for whenever we consider the outlook, so what is the result or the output for the particular condition of the outlook. Okay, so this first we need to consider what is the overall output values. Okay, so we'll be having 9s and 5 no. Okay, 9 times the child has gone to play and 5 times the child has not went for playing. Okay, so in out of 9, how many times the child has gone to play when the outlook is sunny? Okay, so when the outlook is sunny, it is 1, 2, 3, 4 and 5. So out of 5 times when the outlook is sunny, the child has gone for playing 2 times. Okay, so you can see, observe here. So sunny, 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 sunny and sunny 5 times. So this time he has gone for playing, this time he has gone for playing. Okay, so and rest of the 3 was no. So 2 times yes, 3 times no. Okay, similarly when the sun is overcast, so you can check out overcast s, overcast s, overcast s, overcast s. So all the time he has went for playing. Okay, so it is overcast. And rain, when the outlook is raining, 1 2 3 4 5 out of 5 times. So S no, okay, so 3 times he has gone for playing and 2 times he didn't go for playing. Okay, so out of Outlook features, unique 3 features, how many times it has gone for playing, how many times it didn't go for playing. So that we have saw now. Okay, so after this, using these values, we have to calculate the entropy, which will check the purity. Okay, so how that purity will going to calculate? So it will be using the equation, standard equation for calculating the entropy. Okay, so that will decide, use the logarithmic equation for calculating the entropy. Okay, so we'll decide out of 14 we'll be having total 9 positive. Okay okay, so that value, and out of 14 will be having 5 negative. So we'll have minus positive results out of total result, minus negative results out of total results. So we'll take the negative logarithmic value and we'll calculate the entropy of total or overall space. Okay, next, sunny iddaga. So whenever the outlook is sunny, so the entropy is 0.97. When the outlook is overcast, the entropy is 0. So when the outlook is rain, the entropy is 0.97. Okay, so comparatively we are going to calculate the gain also. Okay, after calculating the entropy, we are going to calculate gain also. So how the gain has been calculated? Using this equation. So entropy of S, total space, minus summation of these all entropies, okay, so versus total space. Okay, so that has been calculated here. Minus 0.94 minus 5 by 14 entropy of sunny, minus 4 by 14 of entropy of overcast. Okay, so we'll just check out. Total information gain from the outlook feature is 0.24. Okay, so that thing we have calculated. Okay, so here what we are going to conclude is, from this feature, so whenever the entropy is 0, then means that is highly pure feature. Okay, highly pure or purest feature anta ನಾವು ಹೇಳ್ಬೋದು. Okay, so ಯಾವಾಗ ಅದು ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ, okay, more than 0 ಇತ್ತು ಅಂದರೆ that means purity keeps on decreasing, impurity keeps on increasing ಅಂತ ಅರ್ಥ. Okay, so how that you can decide? So we can see here only one class of values are present for this particular feature. Okay, so that is how the purity has been checked. Okay, so similarly we can calculate the entropy and information gain for the next features. Okay, so just like this. Okay, so for the temperature attribute next. So whenever temperature is hot, what is the pure entropy? What is the, whenever the temperature is mild, what is the entropy? And when the temperature is cool, so what is the entropy? In the similar fashion as we have calculated for the outlook. Okay, so this is going to be calculated using the standard equations. Okay, for the information gain and for the entropy. Okay, finally we got the information gain as 0.02. Okay, for the temperature. Okay, and again we are going to calculate the in the similar fashion. We are going to calculate for the other features also. Okay, for the humidity and for the wind also. Okay, so this is the humidity information gain is 0.15. So for wind it is 0.04. We can observe the values here. Okay, so finally we got to know, so what is the information for information gain for the outlook. So it is 0.24. For that temperature it is 0.02. For the humidity 0.15. for the attribute wind, it is 0.04. We have just put it in a single space here. Okay. So what do you think? So what is which attribute, which feature got the highest information gain? So you can observe here, when the feature is outlook, the information gain 0.24. For temperature it is 0.02, next is 0.15, 0.04. Out of these we can see the information gain for the outlook feature is more, 0.24, and so that is why what we are going to do, so we are going to consider that feature as the root node, which feature is got the highest information gain. Okay, so that feature will be considered as the root node. Okay, from this root feature we'll be having three different classes. One is sunny, overcast and rain. Okay, so whenever outlook is sunny, so what are the different values that we used to get? Okay, from this data set, sunny ಅಂತಿದ್ದಾಗ ಯಾವ್ಯಾವ ವ್ಯಾಲ್ಯೂಸ್ ಇದೆ, ಓವರ್ಕಾಸ್ಟ್ ಇದ್ದಾಗ ಯಾವ್ಯಾವ ರೋಸ್ ಇದೆ, ಆ್ಯಂಡ್ ರೇನ್ ಇದ್ದಾಗ ಯಾವ್ಯಾವ ರೋಸ್ ಇದೆ, ಅದಷ್ಟನ್ನು ನಾವಿಲ್ಲಿ ಸಪ್ರೇಟ್ ಮಾಡ್ಕೊತೀವಿ. ಓಕೆ, ಸೊ ವೆನೆವರ್ ದ ಔಟ್ಲುಕ್ ಈಸ್ ಓವರ್ಕಾಸ್ಟ್, no matter whatever the feature values of other features, okay, so the output is always yes. Okay, so that is clearly specified here. Okay, so this reaches the leaf node, this reaches the end. So now we have to predict whether when the outlook is sunny, what could be the decision he might take. So we need to check out for other features also, other criteria also, just like the previous example. ನಾವೀಗ ಜಾಬ್ ಆಫರ್ನ ಹೆಂಗೆ ಅಕ್ಸೆಪ್ಟ್ ಮಾಡೋದು, ರಿಜೆಕ್ಟ್ ಮಾಡೋದು ಮಾಡಿದ್ವಲ್ವಾ. ಸೊ ಒಂದು ಕಂಡೀಷನ್ ಈ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಿಲ್ಲ ಅಂದಿದ ತಕ್ಷಣ ವಿ ಡೈರೆಕ್ಟ್ಲಿ ಗೋ ಫಾರ್ ರಿಜೆಕ್ಷನ್. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಏನು ಮಾಡ್ತೀವಿ, ಜಸ್ಟ್ ಚೆಕ್ಔಟ್ ಇಫ್ ಎಸ್. ಓಕೆ, ಸೊ ಅಕ್ಸೆಪ್ಟ್ ಮಾಡ್ತೀವಿ ಅಂದರೆ ಈಗ ನಮ್ಮ ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಯ್ತಂದರೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಫೀಚರ್ ನಾವು ಯಾವುದನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊತೀವಿ, ಸೊ ಅದನ್ನು ನಾವಿಲ್ಲಿ ಡಿಸೈಡ್ ಮಾಡಬೇಕು. ಓಕೆ, ಸೊ ಹೌ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡಿಸೈಡ್, ಅಗೇನ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ನೆಕ್ಸ್ಟ್ ಫೀಚರ್. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಫೀಚರ್ಸ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊತೀವಿ ಫಾರ್ ಟೆಂಪ್ರೇಚರ್, ಹ್ಯುಮಿಡಿಟಿ ಆ್ಯಂಡ್ ವಿಂಡ್. So this is one for this feature when the outlook is sunny iddaga. So whatever the days, day 1, day 2, day 8, day 9, day 11. So when the outlook is sunny, day 1, day 2, day 8, day 9 and day 11. So that those days are considered here. Okay, so when the outlook is sunny, so which feature has to consider next? So we are going to again repeat the same process, calculating the information gain for the temperature, humidity and wind by considering this much data set. Okay, we got to know the temperature, like information gain for the temperature, information gain for the humidity and wind. Okay, let me just show you. So this is for the humidity, so we are going to calculate the information gain in the same process. For wind, we are going to calculate the information gain for using the same steps as we did for the outlook. Okay, so finally information gain when the outlook is sunny, so temperature information gain is 0.57 and humidity is 0.97 and for wind it is 0.01. So out of these, so which will got the highest information gain? So which is got the highest information gain? Can observe here, so humidity got the highest information gain with the value 0.97. so when the outlook is sunny, okay, when the outlook is sunny, so here comes the humidity feature. Okay, so let's just show you. Okay, so this is how. Okay, so whenever, and the humidity contains again two features, high and normal. So you can see here high and normal. Okay, and whenever the humidity is high, so it is day 1, day 2, day 8. So you can observe here humidity is high and normal. High idagela no ide, normal idagela yes ide. So it is clearly defined and it is the end nodes yes and no. Okay, now we have to decide which feature has to consider, whether the temperature or wind in the next thing here. ಓಕೆ, ಇಲ್ಲಿ ನಾವೀಗ ಡಿಸೈಡ್ ಮಾಡಬೇಕು. ಈಗ ಈ ಪಾತ್ ಕಂಪ್ಲೀಟ್ ಆಗಿದೆ, ಈ ಪಾತ್ ಕಂಪ್ಲೀಟ್ ಆಗಿದೆ, ಈಗ ಈ ಪಾತನ್ನ ನಾವು ಚೆಕ್ ಮಾಡಬೇಕು. ಇಲ್ಲಿ ಇವಾಗ ಟೆಂಪ್ರೇಚರ್ ನೆಕ್ಸ್ಟ್ ತೊಗೋಬೇಕಾ, ವಿಂಡ್ ತೊಗೋಬೇಕಾ ಅನ್ನೋದನ್ನು ಡಿಸೈಡ್ ಮಾಡಬೇಕು. ಅಗೇನ್ ವಿ ಹ್ಯಾವ್ ಟು ರಿಪೀಟ್ ದ ಸೇಮ್ ಪ್ರೋಸೆಸ್. ಓಕೆ, ಸೊ ಆ್ಯಂಡ್ ಸೇಮ್ ಪ್ರೊಸೆಸ್ನ ರಿಪೀಟ್ ಮಾಡಿದಾಗ ಫೈನಲಿ ನಮಗೇನು ಬರುತ್ತೆ. ಸೊ ವಾಟ್ ಈಸ್ ದ ಇನ್ಫಾರ್ಮೇಷನ್ ಗೇನ್? we used to get whenever the outlook is rainy. Okay, so information gain we used to get is for temperature it is 0.19, for humidity it is 0.0192, for wind it is 0.17. Okay, so as the humidity and the temperature both got the same value, we used to go for the next thing. So what is that? 0.97. And comparatively, so wind got the more information gain. Okay, so then that's why we used to go for the next feature as wind. Okay, now the path is clear. So wind is strong and weak. Okay, so wind strong ಆಗಿದ್ದಾಗ no ಇದೆ, weak ಇದ್ದಾಗ yes ಇದೆ. So it's like this, no and s. So finally all the features reaches its leaf nodes. Idar further navinnenu specify mado agalla. Okay, so because all the nodes have got reached to end nodes, even though the temperature left, temperature feature is left, just because that feature has gone least information gain, that means indirectly it is saying that it is not contributing much for making the decisions. Okay, so that's why we are not going to consider that feature. Even though the temperature is high, the temperature is low, or temperature is normal, we are not going to consider that feature for solving our problem, because that technically that feature is gaining very much less information gain. So that means indirectly it is saying it is not contributing much, it is not so important for predicting the result. Okay, in the similar fashion, we are going to decide whether the particular feature is going to contribute or affect the outcome or not. Okay, so which feature is affecting our result, so those features only we are going to consider for predicting the results. Okay, so this is how finally we are going to solve the problem. Okay, so using the decision tree algorithm. Okay, whenever the outlook is sunny, okay, and the humidity is normal, so we are going to decide. Okay, so no matter whatever the rain condition ಏನಿದ್ರು, so outlook sunny ಇದೆ, humidity normal ಇದೆ, and rainy season ಇದ್ರು ಇಲ್ಲ ಅಂದರು, ಆ್ಯಂಡ್ ವಿಂಡ್ ಅವಾಗ ಏನು ಕಂಡೀಷನ್ ಇದೆ. ಸೊ ಈ ಥರ ಡಿಫ್ರೆಂಟ್ ಸಿನಾರಿಯೋಸಲ್ಲಿ ಸೊ ಡಿಫ್ರೆಂಟ್ ಡಿಸಿಷನ್ಸ್ನ ನಾವು ಮಾಡ್ತೇವೆ ಬೈ ಫಾಲೋಯಿಂಗ್ ದ ಪಾತ್. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ವಿ ಕ್ಯಾನ್ ಸಾಲ್ವ್ ದ ಪ್ರಾಬ್ಲಮ್. ಓಕೆ, ಸೊ ಎಸ್, ಎನಿಬಡಿ ಹ್ಯಾವ್ ಎನಿ ಡೌಟ್ಸ್? Fine, so let us just implement in the Python code. Okay, let's take a same example and create a data set. First we are going to import pandas as pd, and let us create the same data set. Okay, I'll just create this data set using AI tool. Okay, I'll just feed that to the model. we just create the dataset using the AI tool. So I don't want to type that again. So meanwhile, you can just take a steps, make down the steps. Just create a data set like this. Okay, so now I'll create a data frame. So I'll use play data is equal to, so since this data is present in the form of dictionary, so I wanted the data to be in the form of data frame in order to use any machine learning algorithms. Okay, so since they have to be explored, they have to be executed and worked on over NumPy operations, pandas operations, right? So that's why I need to convert this into a data frame. For that purpose, I can use pandas methods called as data frame. Okay, so my data set is now ready. Just run this. Let's just execute this, and after that, so my data will be like play data. Okay, so let's just stop this. So my data set is now ready. I'll just take a look after it by placing the head. Okay, so now you can see. So I have all 14 columns. Okay. So this much only. So this is my data set. Now my data set is ready. Okay, so now let us just implement the decision tree algorithm by following the machine learning workflow. So what's the next step that we have to do here? What is the next thing that we have to do here? After collecting the data set, according to the machine learning workflow, we have to explore the data set. Okay, so for exploration, we are going to use pandas methods and graphs Matplotlib. So we can just explore it by plotting the graphs, how the data is present, what is the relationship and all, so that we can easily observe. Okay, so as in today's session, we are going to concentrate on implementation of the algorithm. So we are not much concentrated on the data pre-processing or the exploration. Okay, so just see whatever is needed. Okay, so in the exploration, we are going to see how many rows are there, how many columns are there, what is the data type, is there any missing values and all. So that thing we are going to explore. Since we can just see here, so we have 5 columns and 14 rows, and out of those no data is missing. Okay, so we need not to do any imputing here. And coming to the data pre-processing, so since the thing that we can do first here, since the data is all in the form of categorical, we can just observe here data, sorry, what is that, play underscore data dot info. So contains all the data in the form of object type. So as I said, so most of the machine learning algorithms are used to expect the data to be present in the form of numerical format. Okay, so that's why what we need to do, we need to convert the categorical data into a numerical data. Okay, so that process is called encoding. So I'll repeat again. So encoding is a process of converting the categorical data into a numerical data, and the standard method that we are going to use for converting the categorical data into a numerical data is label encoding. Okay, so just implement this thing first. Okay, so how we can do, so we need to use play underscore data of what is the column, which is outlook. Okay, so is equal to we need to import the library first. So from Scikit-learn dot pre-processing import label encoder. Okay, so encoder is equal to label encoder. So we can use encoder dot fit underscore transform. It will going to convert and replace the same in the same particular column, specified column. Play underscore data of outlook. Okay, so you can just use okay, you can observe. So this outlook column here is converted into a numerical form. Similarly, we have to apply it for all the columns. Okay, so what I'll do, I'll not write up the same thing for all the columns, specifying all the columns. I just take out the methods, help the mother. We'll just take the help of pandas methods, like exploring the columns. So play underscore data dot columns will give you the list of columns. I'll just take up this. So for I'll just use for columns in play data, my data set columns. So I'll use play underscore data of column is equal to encoder dot fit underscore transform play underscore data of column. Okay, so let us see this, what this will happen. It is actually fit underscore transform. You can see here all the values will be converted. So, and you can observe here every values will be is in the same scale, so 0 to 10. Okay, so with not much scaling variable, so variability tumba illa, variations tumba illa. So for that purpose feature scaling is also not needed, even though that outliers is also not present, since the values are like 0, 1, 2 only. We can manually observe here. So manually ನೋಡ್ತಾ ಇದ್ಮೇಲೆ ನಮಗೆ ಔಟ್ಲೈರ್ಸ್ ಇದನ್ನು ಇಲ್ವ ಅಂತ ಗೊತ್ತಾಗ್ತಾ ಇದೆ. ಸೊ that also is not needed. So let's just move on to the next step. So that is split the features and target. Okay, so next we need to split up the entire features into independent features and the ಡಿಪೆಂಡೆಂಟ್ ಫೀಚರ್ ಅಂದರೆ ಟಾರ್ಗೆಟ್ ಏನಿದೆ ಔಟ್ಕಮ್ ಏನಿದೆ ಆ್ಯಂಡ್ ಇನ್ಪುಟ್ ಆಗಿ ಯಾವ ಫೀಚರ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ಸೊ ದ್ಯಾಟ್ ವಿ ಕ್ಯಾನ್ ಸ್ಪ್ಲಿಟ್ ಅಪ್ ಹಿಯರ್. ಆ್ಯಂಡ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಆಗಿ ನಾವು ಡಿಪೆಂಡೆಂಟ್ ಫೀಚರ್ಸ್ನ ವೈ ಅಂತ, ಇಂಡಿಪೆಂಡೆಂಟ್ ಫೀಚರ್ಸ್ನ ಎಕ್ಸ್ ಅಂತ ಇಂಡಿಕೇಟ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ದಟ್ ಮೀನ್ಸ್ ಇನ್ಪುಟ್ ಈಸ್ ಎಕ್ಸ್, ಔಟ್ಪುಟ್ ಈಸ್ ವೈ. Okay, so here how we can split is play underscore data my dataset. In my dataset, so what are the columns that I am going to use? So locations of all the rows. If I just simply give colon, it will consider from the first to last. So all the rows. So what are the columns? That is outlook, temperature, humidity and wind. Okay, so first to last. Okay, so except last one, so that you can give, or else you can just use, so you can give 4. So dot values. Okay, so in similar fashion values. You can see here all the values are present here. Similarly, y is equal to play underscore data dot I log of all the rows. So last column, because that is the one our output values. So our x and y are now ready. So next we need to split up the entire data set into a training and the testing portions. Okay, for that purpose we need to import the library from Scikit-learn dot model selection import train test split. So here we have to give the order like x train, x test, comma y train, comma underscore test. Okay, so train underscore test underscore split. Here we need to pass the entire data set with the train and test size. Okay, so I'll use 20% of the data for training and 80% testing for, and 80% of the data for training. Okay, so next, we have just split the entire data set into training and the testing portion. Now it's time to select the model. So as we said, so our model is decision tree. So that model is defined inside the library from Scikit-learn dot tree import decision tree classifier. Okay, so you can use dt is equal to decision tree classifier. So similarly, how we are going to select the models? We have created a model, we have selected the model and created an object. Now it's time to train the model. How? dt dot fit x underscore train comma y underscore train. We need to feed that model with the training data set. Okay, so our model is trained out. This is model selection and this is model training. So model training is done. Now it's time to evaluate the model. How we can evaluate? Just predict the values for the test input. Okay, so ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ಎಂಟೈರ್ ಡಾಟಾ ಸೆಟ್ಟಲ್ಲಿ, ಸೊ ಇಷ್ಟು ಡಾಟಾ ಸೆಟ್ಟಲ್ಲಿ 80% ಆಫ್ ದ ಡಾಟಾನ ನಾವು ಟ್ರೈನಿಂಗ್ ಪರ್ಪಸ್ಗೆ ಕೊಟ್ಟಿದ್ದೀವಿ, 20% ಆಫ್ ದ ಡಾಟಾನ ಟೆಸ್ಟಿಂಗ್ ಅಂತ ಯೂಸ್ ಮಾಡ್ಕೊತೀವಿ. ಸೊ 80% ಆಫ್ ದ ಡಾಟಾ ಅಂದರೆ ಆಲ್ ದ ರೋಸ್, ಆಲ್ ದ ಕಾಲಮ್ಸ್ ಯು ಹ್ಯಾವ್ ಗಿವನ್. ನಾವು ಇಟ್ಸ್ ಟೈಮ್ 20% ಆಫ್ ದ ಡಾಟಾ ಅಂದರೆ ಅಷ್ಟು ಮಾತ್ರ, ಅಂದರೆ ಇನ್ಪುಟ್ ಮಾತ್ರನೇ ನಾವು ಈಗ ಯೂಸ್ ಮಾಡ್ತಾಯಿದ್ವಿ. ಇನ್ಪುಟ್ ಅಂದರೆ ನಾವು ಇಲ್ಲೇನು ಕೊಡ್ತಾ ಇದ್ದೀವಿ, ಇಂಡಿಪೆಂಡೆಂಟ್ ಫೀಚರ್ಸ್. ಸೊ ಇಂಡಿಪೆಂಡೆಂಟ್ ಫೀಚರ್ಸ್ ಯಾವುದ್ಯಾವುದು, ಔಟ್ಲುಕ್, ಟೆಂಪ್ರೇಚರ್, ಹ್ಯುಮಿಡಿಟಿ ಆ್ಯಂಡ್ ವಿಂಡ್. ಓಕೆ, ಇಷ್ಟು ಫೀಚರ್ಸ್ದು ವ್ಯಾಲ್ಯೂಸ್ ಏನಿದೆ 20%, ಅದನ್ನು ಮಾತ್ರ ನಾವು ಏನು ಮಾಡ್ತಾ ಇದ್ವಿ, ಯೂಸ್ ಮಾಡಿಕೊಂಡು ವಿ ಲೆಟ್ ದ ಮಾಡೆಲ್ ಟು ಗಿವ್ ದ ರಿಸಲ್ಟ್ಸ್. ಓಕೆ, ಆ್ಯಂಡ್ ದ್ಯಾಟ್ ವಿಲ್ ಬಿ ಸ್ಟೋರ್ಡ್ ಇನ್ ypred. ಓಕೆ, ಸೊ ದ್ಯಾಟ್ ಕ್ಯಾನ್ ಬಿ predicted using predict model. So predict of x_test. So it has now done. Now it's time to evaluate in ಮಾಡ್ತೀವಿ. So we need to check the accuracy. Okay, how we can check the accuracy of a classification model? So what are the metrics used for checking the accuracy of the classification model? ಯಾವುದು? ಕ್ಲಾಸಿಫಿಕೇಷನ್ ಮಾಡೆಲ್ ಅಕ್ಯುರಸಿ ಹೇಗೆ ಚೆಕ್ ಮಾಡ್ತೀವಿ? We have different metrics, right? We have precision, F1 score, recall, confusion metrics, and accuracy, right? So those metrics we can use to check the accuracy of the classification model. Okay, so just from Scikit-learn dot metrics import confusion matrix comma accuracy. Okay, so both accuracy score, both you can use. So accuracy is equal to accuracy score of y_test comma y_pred. So these are the comparison between test actual results and the predicted results. Okay, so my accuracy is, so 1, it is giving 100% results. Okay, 100% correctly it is predicting. Okay, so you can vary the training size, you can change the training and the testing size. We can change, we can see the difference in accuracy. So whenever you feel the accuracy can be increased, optimized, so then you can just vary the training data set. Okay, so model training ಅಥವಾ ಟೆಸ್ಟಿಂಗ್ನ ಜಸ್ಟ್ ಸ್ವಲ್ಪ ವೇರಿ ಮಾಡಿಬಿಟ್ಟು ಚೆಕ್ ಮಾಡಿ. ಸೊ ಮಾಡೆಲ್ ವೇರಿ ಆಗುತ್ತೆ, accuracy ವೇರಿ ಆಗುತ್ತೆ. Okay, so this comes in the phase of optimization, optimize the model. Okay, so there you can improvise the accuracies of the model. Okay, by just changing the training portion, by just feeding more data for training, or predicting less, using less data for testing. Okay, so that you can do whenever you want to improvise the performance of the model. Okay, for 30% of the testing size and 70% of the training size, we can see, so our model is giving 80% accuracy. Okay, so this is how I can implement the decision tree algorithm. Okay, so you can also predict it for the new sample. Okay, so let us just check it for new sample. This is called deployment. So new sample values is equal to, so dt dot predict of, so I'll use my outlook. Let us check the first value only. My outlook is sunny, hot, high, temperature is hot, humidity is high, and wind is weak. So what's the value? 2101. So whenever we are deploying it, we need to give the numerical values only. We can create a user interface for this. So there you can give the categorical data only. From that you can get the internal encoding technique. You can create a function, and thereby the categorical data is converting it to numerical data, and finally it will going to feed that into a model, and that will finally giving you the results. Okay, so for this set of values, my result is 0. So then that means my result is no, he is not going to play the game. Okay, so that's how you can implement the decision tree algorithm. Okay, so let me just draw a tree for this. Present. Okay, let us just copy this code. So let's just plot the decision tree classifier for our data set. Okay, so now we just we'll be having a library called as tree. Okay, so which will be used to draw the tree which is created, which is built for the data set given, trained data set. ಈ data set ಏನು ಕೊಟ್ಟಿರ್ತೀವಿ ಇದಕ್ಕೆ ಏನು ಯೂಸ್ ಮಾಡಿರುತ್ತೆ, ಯಾವ ಥರ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಎಲ್ಲ ಆಗಿದೆ ಅನ್ನೋದಕ್ಕೆ. ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ದ ಫೈನಲ್ ರಿಸಲ್ಟ್. Okay, so x of 0 ಅಂದರೆ this is 1. First x of 0, this is outlook ಅಲ್ವಾ. x ಅಲ್ಲಿ ಏನು ಕೊಟ್ಟಿದ್ದೀವಿ, 0 to 4 ಅಂತ ಕೊಟ್ಟಿದ್ದೀವಿ. that is first one is outlook. 1 ಅಂದರೆ temperature, 2 ಅಂದರೆ humidity, 3 ಅಂದರೆ wind. Okay, you can see x of 3 is wind. So in our graph also it is coming last wind. Okay, ಇದಕ್ಕೆಲ್ಲ ಜೀನಿ ಔಟ್ಪುಟ್ ಎಲ್ಲ ಏನು ಬಂದಿದೆ ಅನ್ನೋದು ನಿಮಗೆ ಟೆಕ್ನಿಕಲಿ ಇಲ್ಲ ಪ್ರೋಗ್ರಾಮಲ್ಲಿ ಕೂಡ ರನ್ ಮಾಡಿದ್ರೆ ಸಿಗುತ್ತೆ. ಓಕೆ, ಫಿಗರ್ ಸೈಸ್ ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಇಂಪ್ಲಿಮೆಂಟ್. Okay, you can see it is outlook, it is wind. Again it is taking the values, different values. Okay, x of 2 is not considered. x of 2 andre 0, 1, 2. So it is humidity, it is not considered. Okay. Okay, so that's how this algorithm can be implemented. Okay, so that's all for today. So if you have any doubts, you can ask me.